Hey folks, how does an LLM gateway orchestrate requests? Most teams place a gateway between the agent and the LLMs. This component sits in front of the models to handle routing, fallback, and token management. When the agent sends a query, the gateway inspects the request, checks token budgets, and routes to the best available LLM. If a model is overloaded, it falls back to another. It tracks usage and enforces rate limits, preventing a runaway agent from burning through the monthly quota. With these capabilities, the gateway becomes a single control point for all LLM interactions. That's the basic gateway. Now let's connect it to the actual models. With that gateway in place, we add two LLM endpoints, primary and fallback. The primary handles normal traffic, while the fallback steps in when needed. From the gateway, a solid route leads to the primary model. A dashed fallback path goes to the secondary model. Normal queries flow to the primary first. If the primary fails with a timeout, the gateway reroutes to the fallback. This ensures reliability automatically. In production, this dual model setup ensures high availability. Now we have a complete path from agent through gateway to either model. On a normal request, the gateway routes to the primary LM and returns the response. The agent sends a query to the gateway. The gateway then routes the request to the primary LM. The primary LLM receives the request and generates a response. It sends the response back to the gateway. The gateway receives the response and forwards it to the agent. The agent receives the response and the round trip is complete. That's the smooth flow, but what happens when it breaks? But when the primary is unavailable, the gateway falls back to the secondary model. The agent sends a query to the gateway. The gateway attempts to route to the primary, but receives a timeout error. The primary is marked as down. The gateway then selects the fallback route. It sends the query along the dashed edge to the fallback model. The fallback model is ready and processes the request. Once processed, the fallback sends a response back to the gateway. The gateway forwards the response to the agent. The agent receives the answer. The gateway monitors for timeouts and errors. Fallback works, but it relies on the gateway's internal decision logic. Beyond routing, the gateway also manages token consumption to prevent abuse. It allocates a token bucket with a per second limit to each agent session. When the agent sends a query, the gateway checks the bucket. If tokens remain, it deducts one and forwards the request to the primary LLM. But if the bucket is empty, the gateway returns a decline response to the agent signaling rate limit exceeded. After the fill interval, new tokens appear. The next query gets processed and routed normally. Token management is one internal, function routing is the other core. This routing and fallback pattern is exactly how API gateways like Kong and Envoy work, but for tokens and LLMs. The LLM gateway sits between the agent and the models, forwarding each query to the right destination. When the primary model can't handle the request, maybe it's over budget or too slow, the gateway detects the failure and reroutes to the fallback seamlessly. Kong does this for API requests, Envoy does it for service meshes. Our LLM gateway applies the same idea to model calls, route based on token availability, latency, or cost. You can define rules that mirror Kong's route matching or Envoy's weighted clusters, but tuned for language models. That's the Kong Envoy like behavior. Intelligent routing with graceful fallback. Let's compare the happy path with the failure scenario side by side. In the happy path, the agent sends a query to the gateway, which routes to the primary LM. But when a failure occurs, the gateway sees an error from the primary and automatically reroutes to the fallback LM. Now let's see both paths highlighted. The happy path routes directly to primary, while the fallback path only activates on failure. This transparent failover means the agent never sees a disruption. The gateway chooses the best available LLM. You've seen how an LLM gateway handles both success and failure transparently. We started with an agent and added a gateway that routes requests to a primary LLM with the automatic fallback to a secondary model. Inside, the gateway manages tokens, and routing logic, much like Kong or Envoy. That's the architecture behind modern LM gateways. That's how an LM gateway actually works under the hood. Subscribe to this channel for best practices for system design. Catch you in the next one.